we are not waiting for others. And remember, last week we were discussing on pointers, on arrays. But today I want us to start on pointers. But I think on a cut that we did, I saw that there is some problem on loops. So mostly when you are using loops and understanding the questions. So please, I would urge the moment you are revising, can you revise mostly on loops and be able to understand on how we can be able to use them the time that you require them. So please allow me to just have a recap on last class. And I think we were looking at arrays, and we were able to make sure that now the user is able now to work with different arrays. And for today, I want us, maybe we can start from pointers. We can start from pointers. And at the moment we are talking about pointers, what we need to understand, let me share the screen. So, so if you look at pointers, first of all, we understand about definition of pointers. And maybe allow me to use the PowerPoint so that I can give you the analysis of these pointers that we are supposed to discuss. And we know that first of all, we start with definition. So we will start with definitions. Then after definition, we will look at syntax. We look at syntax. That is the syntax of a pointer. Then after that, we look at the implementation of these arrays, of these pointers that we have. And when you look at the implementation, mostly we will be looking at coding. So how should we implement these pointers that we have? Just a minute. So if you look at the class that you are supposed to have, mostly we look at the address. And when you look at the address, we look at how we can be able to store data. And when you store data, we will be able to look at now. We will be able to look at now the way that you can be able to store data. But how are we supposed to store? So in this case, when you talk about pointers, because you are saying this is a variable that stores address of another variable, And when it is storing address of another variable, we are saying, suppose I have a variable A. So this A, maybe we assign it as 10, as a value 10. So if it is a pointer, let's say there is a pointer A, that means it can store, just a minute. So suppose we have a pointer B. And we have A. So it means the value that is stored on A, because we have already assigned A, it means the value has been stored in a memory location for A. So the value that you store in a memory location for A, so this B has mandate to store this 10 in a memory. So it has that mandate to store this 10. So it's like now, if you come here and we say we're executing, so maybe we say print F, maybe we are print F B, where now this B is a pointer. Now we can say B will be 10. So A and B will be able to store 10. So in this case, that's why we understand that when you are working with the pointers, you are saying pointers is a programming language object whose value refers to or points to another value stored elsewhere in a computer memory using its memory address. So it's like now we are saying B, because B is now the pointer, and B, we say it points, so we can have a, so B points A, remembering that A is not a pointer currently. And because A is not a pointer, so B is pointing A. So we have that arrow that means that we are pointing. So this now becomes the address. So the whole of this becomes now the address. So how will you be able to define a pointer? So the first thing is to understand about the syntax. So the syntax of a pointer, we use asterisk. So when I use asterisk B, I'm referring to a pointer B. So that is the case that we are having here. That's why we are saying it references that. So we can say a pointer references a location in a memory, and obtain the value stored at that location is known as dereferencing the pointer. So this value that is stored in this memory. So if we have already stored 10, that value that we have already stored, it's called dereferencing memory. So in this case, we need to know on how we can be able to assign the pointers in this, because it's a data structure. So what is a pointer now? So already we have defined this pointer, and we need now to look at now the benefits of this pointer. So why do we need a pointer? So the first is to handle arrays and data table efficiently. So remember, when you're using pointer, you can be able to reference millions of data. Then the pointers support dynamic memory management. So we are supporting dynamic. So when you talk about dynamic, it means it can keep on changing. So we don't have some presentation of data that is fixed. So it keeps on changing. So it is dynamic. So if you have a memory, like now, if you look at in an array what we decided on an array, it is able to change with the time. It is able to change with the time at a given point. Pointers helps to return multiple values. So automatically, you have seen here, when you are returning A as 10, we can still return B as 10. And you'll be able to define that. So let's look at these values, and we understand that when now you can be able to reference multiple values, we increase the speed of execution. So these are benefits or advantages that you can have on pointers. And if you look at most of the cases, you'll be able to look at now the use of pointers in queues, stacks, and sorting algorithms that we have. So for the pointer declaration, so in this case, we are supposed to understand that when you are declaring a pointer, we have to use what you call type. Then we have variable name, type, variable name. So already I have defined here where we are saying maybe we can have a pointer called K. So we are saying type pointer's name, which is now always defined as maybe an integer. Then because we are using a pointer, we use asterisk P, maybe you can use as a pointer. So this is now a variable that is a pointer. But how will it store address of another variable? So that is what we are supposed to look at here. So already we have defined a variable called P, but this P is supposed to store values for another variable. So that's why we are looking at now this explanation where we are saying after we declare, we need to have an operator that can be used to store value. So that operator that it's supposed to do that is an ampersand. So this is an ampersand. So we use an ampersand, meaning if we have declared a value R or R, then we have a pointer P. Then we have a pointer P. We are saying this P is storing address of R. This P is storing address of R. So that means maybe if now R is equals to 5, so automatically this P is storing the address of R. That means the address that you find in P is the same as the address that you find in R. We can say maybe the address is 1, 2, 3, 4, 5. So this address that you find in R, which is 1, 2, 3, 4, 5, is the same address that you find in P, because we have already said P is a pointer. So if you look at this example that we have, we are saying C contains two special pointers operators, that is asterisk, mostly when you're referring to a pointer, and ampersand for addressing. The operator returns the address of a variable, it proceeds. The asterisk operator returns the value stored at the address that it precedes. The asterisk pointer operator has no relation to the multiplication operator. So please note this. It doesn't have any relations with the multiplication. So when you're using it, we don't say that we are multiplying P. We are now creating a pointer. And that's why we can see this question here, where we have said we have a pointer P and we have a variable Q. Q has already been assigned to 100. Then we can now say the pointer P is storing an address of Q. So we assign address of Q to pointer P. So for this case, we can say we are assigning address of Q to pointer P. So in this case, now we are able now to understand that if we need to get the address of Q, now we can use the asterisk P as an output. So this displays the address of this. So displays Q's value using pointers. So it means the output for this will be 100. So the output will be 100. Now I want to change this. I want to change this code. And the way I want to change this code, allow me to copy this code the way it is, and then I can maybe use a new slide here. So in this case, so if we can remove this, so in this case, what we are saying is, we have a pointer P, but this pointer P has another variable Q. So Q has already been assigned to 100. So it means if you want to store the address of Q, we can say P is equals to ampersand Q. So it means the value, the address that is in Q has already been copied. So we are doing what you call copying the value. So we are copying the address to P. So it means the moment I use asterisk P as an output, so it means automatically we are now executing. For this, the answer will be 100. Because the moment we are trying to store an address for Q, we are still storing the value for this Q in pointers P. But suppose I want to change this. So instead of using that, I use printf. Then I say percentage %d that. Then I open that. I say $P. So it means P is now termed as a pointer here, but we have said ampersand P. So automatically, the answer here will be the address of Q. Well, maybe the address of Q maybe can be, maybe we can say, let's say that is address can be, so it depends with the program. So when you write, it automatically generate an address. So this address is 1, 2, 3, 4, 5. So this one is supposed to give you this address. If I change this and I want to give it Q, the same case, it stores the address. If I change this maybe to Q, it now gives you 100. So because now we have already assigned Q to 100, when I output Q, automatically it will be 100. But if I use a $sign, automatically it will be an address of this Q, which is pointed by P in the reference. So this case, when now you are accessing these pointers, you are doing what you call referencing. And that's why we have said referencing is when we are trying to access the values of these addresses that we have within a given point. So I think up to now, maybe we are able now to address on how we can be able to initialize array, pointer, and how we can be able to define the pointers in this program. So I think maybe I can get some clarification from there. Are we able to follow what we are discussing? Maybe are you able to understand on how we can be able to define array pointer, on how we can get the advantages or what we call the benefits of these pointers? Because now we are able now to execute more codes, more values within this. And then are we able now to call the addresses and be able to call the values within pointers? So maybe I can get some clarification from there. Maybe I can get some comments from there. So can I get some comment? Are we understanding, or maybe I can repeat that? I'm waiting, please. I'm waiting, please. Okay, I have seen a question here. I can call it a question. Is it right to define pointers as variables whose values are memory address? So I think this is not a good point to use it, because when you use a pointer, we need to be very clear, because when you say it is right to define pointers as variable whose values are memory address. Okay, if you look at the definition, we can have some clarification on this. If I have 2 marks, I can give you 1, but we must be able to come up with a very clear definition. Because when you say a pointer is a value that has a memory address, or whose value are memory address, that one is not right. Because we are saying this pointer can store value and can store address. So for this case, we are now confusing the statement. So the only way that we can be able to define is saying it is a variable that stores values of another variable or address of another variable, because we are looking at addresses and values for these values that you have, for these variables that we have. So we are not only looking for values. We are not only looking for values. We are still looking for values and addresses for these variables that we have. And that's why we have said, if you look at this P is termed as a pointer. And it is not termed as a pointer for storing only values. It is termed as a pointer for storing values and addresses for this value. So that's why we say it is a memory, it is a variable that stores memory addresses, or that stores addresses of another variable. Stores addresses of another variable. Remember here, it is not storing its own address. It is storing addresses of another variable. Meaning, within that address, you have the value and you have the reference for that, which is termed as an address for that. So I think, Onyango, it's not bad to explain that, but now it is not clear whether we are looking at values or we are looking at address. Because here we are saying pointers as a variable whose values are memory address. That one is okay, but it is not given it clearly what you define as a pointer. So are we together now? So when you're defining it, it's good to define as a variable that stores memory addresses for another variable. Memory addresses for another variable. Do you have any other question? Yes, Grace? I can see you are typing. So you can still use mic if you have a question, please. So I proceed. Okay. So Rachel, do you have any question? Carl, do you have any question before I proceed? Okay. So I think I can proceed. Today, I want to have a very short lesson, because I want us to know on how we can be able to implement these pointers. And I don't want to start implementing pointers in an array for this level, but we'll be able to know on how we can be able to implement arrays in this using these pointers. So I think we can still interpret the code that I'm having here. And if you look at the code that I'm having here, it's a very short one. And we have already said we have a pointer. Let me maybe use this. Maybe I can use this code. And maybe I copy it somewhere else. So for this case, we are saying we have a pointer P and another pointer Q. Then this P is reference. So we are saying P is referencing. It's like we are using reference. So it is referencing. So it is referencing Q. It is referencing Q. And when it is referencing Q, we have already assigned pointer to 199. Pointer to 199. Now the question is, what will be the value for Q? So when you output Q, so printf, Q value is, remember we have said when you are storing this value, remember here we have assigned pointer to 199. So it means this is now storing the value, and still we can reference the address of this pointer. So it means because here we have already used an address Q, automatically the value is copied to Q memory. The value is copied to Q memory. So in this sense, we can say the value of Q is 199. The value of Q is 199. But now, if I change this and I use an ampersand, that is the point that now you can reference the address. And that is why we are saying dereferencing the memory address. Dereferencing. Because now we can only give the address. But here, we are giving the value. But the moment we give an address, we are now dereferencing. So for this case, the answer is 199 in that case. Irrespective of how we have assigned the value, what you need to note is that, do we have this address? Do we have this address? If we don't have this address, and the value was like that, so this Q, the answer will be 0. The answer will be 0. Because we don't have a memory, we don't have a value that has been referenced by this pointer. So for this case, it can result to syntax error, or if it will not result to syntax error, the answer will be 0. That's why we always use an ampersand to mean that this is the value that is supposed to be referenced by a given pointer. And that's why we look at this interpretation and we say the asterisk operator applying to P can be vampirized as at address. Meaning, therefore, the printf statement can be read as printf the value at address Q, which is 100. If you look at now the question that was there, and if you look at this now, the reference will be 199. So the value will be 199, which has already been referenced by this pointer that we are having. So if now we want to advance this and we want to define an array, we can say int, maybe asterisk P, which is a pointer, and then maybe we have int Q, which is a pointer that is supposed to store 20 values. So in this case, we can say P is storing a variable P, a variable Q. So P is referencing Q. So if P is referencing Q, so in this case, if P is referencing Q, what we are referencing the memory address of this array. The memory address of this array. So the importance of referencing is to speed up in execution. So when I'm writing, maybe I say printf, I'll be able to say maybe percentage %d, I'll be able to say P you now reference Q. You now reference Q. So in this, now it is already able to execute. So when you are now executing the statement in array, we use the single arrow. We use the single arrow that is given here. So in this case, we are able now to understand, the program is able now to interpret the array that we have. So for now, maybe I can welcome a question up to that point so that we can be able to proceed from there. Maybe on how we can be able to use arrays. Where we have said, when you are using arrays, we need to reference using a pointer. So this now becomes a pointer that is supposed to reference those values in an array. But when you are not using an array, we are not supposed to use that. We can still use p dot q. P dot q. So those are two methods that you can reference a pointer using that. So is there any question up to that point? Is there any question up to that point? So I'm waiting for a question. Maybe we can have a question from there, maybe. Okay, so I have gotten an answer from Onyanko, so we don't have a question. Okay, so I think I can proceed from there. So I want you to go to your portal. There are some assignments that I have given you, of which now this array in pointers. I don't want to explain it at this point because we'll be able to explain it the moment we'll be looking at sorting in algorithms. So you'll be looking at it in sorting, and we'll be able to elaborate further in this. And that's why we have said, if now we are using an array, and we have declared an int r, and this is an array which is having 10 elements. So for this case, maybe if I have another p, so p is equals to p, which is a pointer, so we can say p is equals to ampersand r, which is a pointer. So I think you can reference that. So we are now using this as a reference, and for this reference now we can say it's an array. So we can say for, maybe we have int I is equals maybe to 0, or maybe we can say it's 1. I is less than or equal to 10. Remember, we have started with 1, then we have I plus plus. So in this case, we can now open, and because we have already referenced this, maybe we can say printf, enter the values. Then you can have scanf %d, then we have ampersand. The way we declare arrays, then we have r into i, So for this case, now we have already entered the values of this, so we must be able to reference this. So the moment we want to get the output, so we can have the output for these values. So we have that. So we can say we have printf to %d, then we have r, which references which references, not R, sorry, P, sorry, P, which references R into I, R into I, R into I. So in this case, the values that are in array R, the values that are in array R are now stored in pointers P, are now stored in pointers P. So in this case, if I come here and maybe I close this, or I come here and I change, I replace this. So if I replace this, the whole of this, and I want to replace this with maybe I can replace this with what? Maybe I replace with P. So I replace it with asterisk P. So it means all the values that we have already stored in P will be displayed. So if I have maybe 8, 10, 6, etc., I will be able to display them because already we have defined them in this array. So we'll be using these arrays. The moment we'll be looking at now arrays in sorting. But for now, you can be able to understand how the arrays are supposed to be used in the class. And that's why we are saying one can assign an address to a pointer by using an array name or using an address operator. So already this one, we have already solved that. From the previous example, one is assign an address of beginning of array, which is cell to that. So I think the question that is now asked here, we have already answered it, and we don't have any issue on that when you're using the pointers. So I think if you look at this, we have an array. If you still need to advance in it, program that uses a for loop that count from 0 to 9, it pulls the numbers using a pointer. So we declare an array, we declare values. So remember, we want to print numbers 0s to 9 to 10 or 0 to 9, but we must reference using a pointer. So I think this one we have already worked with it, and this question is clearly noted within that. So we can still further demonstrate this. I think we have already given the demonstration where we have U1, U2 into V is equals to 3, pointer PV. So 2 times that, PV is that. So the values that are in V, so V already is 3. So 3 is stored in PV. So it means the moment I want to output the value of PV, so PV will be 3. But if I want to have U2 will be 2 times PV currently is 3. So it is 3 plus 5, which is 8. 8 plus 8 times 2, which is 16. So I think the answer is already given as that, because we have already assigned the value that was in V to PV. So automatically the whole of this is replaced with 3. So 3 plus 5, which is 8, then times 2, which is now supposed to be 16 as an output. So for now, we can rest at that point, because that is the end of what we are supposed to discuss on pointers and how we are supposed to display the pointers. Unless there is a question, maybe we can ask this question before we go to chat room. Please, you can ask questions if you have questions. Okay, Onyango, I have seen your question. I has not been declared. When you're using a for loop, we can declare I either inside the for loop. It is still allowed, but I would prefer when you're writing a program, you declare it outside the loop. But for me, I have declared it inside the loop. It is allowed. It is allowed. There is no harm when you're declaring like that. I think I have answered that question, Mr. Onyango. Have I answered the question? So please, we can chat. We can maybe use emojis. I have seen Onyango has used emoji. Is there any question, please? Any question, please? You can ask if you have a question. Today, I don't want to go beyond there because I don't want to mix pointers with function. So next time we will start with the functions. And when we do away with functions, automatically we will be able now to go to sorting algorithms or listing or queues and stacks. And those are the topics that we need to be very serious when you are listening. So remember, in certificate, I will never ask you a question on how to write a program, maybe using a sorting algorithm. I have never seen a question on that when you're using NEC, but it's good you understand because we are not doing this unit for only your exams. So if there is a question, I have gotten an answer from Onyango, so maybe we can have another question. So call Felix, Minor, Rachel. So we can have a question. So do you have any question? Okay, Grace has answered that. We don't have any question. So I think for now we can proceed to the quiz that I have already set in our portal. So please, can you go and answer those questions? Then after that, we'll be having our chats. Remember, don't go away. We are still having time. Our class is supposed to end from 1. We still have 2 hours. That is 1 hour and some minutes. That is 15 minutes. So if there is a question, we can maybe communicate via the chats if there are no questions. So Rachel, do you have any question? Okay. Call. Okay, so can we move to chat room now? Can we move to the chat room? First of all, we do the quiz. There are some quiz that I have already set. So is it possible we can move there? Maybe I can get some feedback. So can we move to those quiz? Can we move? Okay. So remember, I have marked your cards and there are some challenging questions that I posted on your portal. So please, can you go and revise those questions? I already set the questions. I answered the question that were having some issues. And I think if you have gone to your portal, you can see the answers for those 2 questions. So please, can you go and revise those 2 questions or the answers that I have already sent to your portal so that now we can be able to understand where you went wrong when you're answering question on your card. So please, let us move there. And I want you, so Peter, I think you have joined, and we are moving to the chat room. So please, if you have any question, you can ask. And then maybe we proceed. So let us go to the chat room. And after we go to the chat room, there are some questions that I have already said. You do those questions. Then after doing those questions, I will set a forum that we can maybe communicate and we answer the questions that are there. Let us move there.